So the next chapter that we are going to cover in chemistry is of liquid solutions and colligative properties. Now this is a kind of new chapter and it involves a lot of new concepts, but it becomes very easy if we just remember the key formulas and the key concepts of this chapter. Getting started with the first problem. This is a pretty easy problem and the most fundamental problem of this chapter. We have the addition of a 0.643 gram of a compound to 50 ml of benzene whose density is given. This addition of compound in this pure solvent causes the lowering of freezing point of benzene from 5.51 degrees Celsius to 5.03 degrees Celsius. We need to find the molecular weight of this compound which is added to this benzene solvent, and the Kf for benzene is given. So applying the simple formula of depression of freezing point, this is equal to Kf for the solvent into molality. Here molality can be written as moles of the solute upon the weight of solvent in kilogram. Moles of solute can be written as weight of solute upon molecular weight of solute divided by weight of solvent in grams, that is in kilograms, that is we multiply 1000 in the numerator. Now the value of Kf is given to be 5.12. So our depression of freezing point is also given. Earlier the freezing point was 5.51 and now it became 5.03. So depression is 5.51 minus 5.03. This is equal to Kf times weight of solute. We have 0.643 grams of a solute, that is a compound. So this is 0.643 into 1000, that is 10 power 3, divided by molecular mass of solute, which we need to find out, divided by weight of the solvent. We have solvent, volume given and density given, and hence the weight is 50 into 0.879. On solving this equation, we get the molecular mass of the solute to be equal to 156.06 grams. This is the most fundamental question of this chapter of liquid solutions and colligative properties. The main concept involved was that if a solute is added to a pure solvent, which was benzene in our case, it causes the depression of freezing point of that solvent. In the same way, it also causes the elevation of boiling point. The simple formula that was involved in this problem was depression of freezing point is equal to Kf, which is the constant or the freezing constant for the solvent, into the molality, and hence our final answer for the molecular mass of the solute is 156.06 grams.